In the previous class, we started discussing about the parallel RLC circuit, source free response of parallel RLC circuit. So now we will see the forced response of series RLC circuit, and after that we'll see the forced response of parallel RLC circuit. Right. Forced response of series RLC circuit. This is also known as step response of series RLC circuit, also known as step response of series RLC circuit. So let us have a circuit which is having a series RLC elements like this. So assume that this switch is closed at t equal to 0 seconds. Assume that this switch is closed at t equal to 0 seconds. Say it is Vs, this is R, L, C, and this current is I. So this current is I. So this is voltage across capacitor V, voltage across capacitor V. All right. So now what we have to do is we need to develop a characteristic equation. In other words, we need to develop a second order differential equation from this circuit, right? So what is the best way? So this is current I, right? So if we apply KVL, here, so what you will get? So R into I, right, plus di by dt plus voltage across capacitor V, which is equal to Vs. Agree?
Yes, sir.
So, right. So here, what we have to do is we can simplify this one, or so no need to analyze everything, no need to differentiate and everything. So we can simplify that. So we know the current I. If you know the capacitor voltage, what is the current I? If you know the capacitor voltage, what is the current I?
C dV by dt.
C into dV by dt, right? Okay. So substitute in place of I. So this is series connection, right? So therefore the current is common to all. So therefore I equal to C into dV by dt. Substitute here R into C dV by dt plus what is the next term?
LC into
LC into d square V by
d square V by
dt
dt
square plus
V equal to Vs.
Vs, right? If we rearrange this one, or we need to divide this one with LC, so this will be d square V by dt square plus, to divide this one with LC, that will be R by L into dV by dt plus, what is the next term? V by LC and Vs by LC. This is the one, right?
Yes, sir.
Okay. If you remember, so what is the characteristic equation of the series RLC circuit? I think it will be d square I by dt square plus R by L into di by dt plus
1 upon LC.
I by LC,
I upon
which is equal to 0, right? This is the one. So if you observe that, so this is in the same manner, right? So this characteristic equation also in the same manner, except the difference that instead of 0, so we have Vs by LC on the right hand side. Okay. So now, so in one of the previous classes, we discussed that V of t, so that the overall response of voltage across capacitor, so which is equal to V transient of t, so that is the transient response of t plus V steady state response of t. You remember this, right? You remember this equation? So we divided this into two parts. So one is the transient response part and steady state value. So when we discussed, I think we remember what is the equation V of t, so which is equal to, what is the V of t equal to V infinite plus V of 0 minus V infinite into e to the power of minus, not alpha t, minus t by
Tau.
tau, right? So this is the one. So if you observe that, if you decompose this one into two components, so one is V of infinite term. So V of infinite term. So what else we have on the other side? Or else if you see that, so this is the steady state value, right? And this is transient value. So this is steady state response and this is transient response. The same manner, so we divided this into two parts. So one is steady state value and its transient value, right? So for example, if steady state value is equal to 0 in case of source free response, so in that case you're left with V of t, which is equal to V of 0 into e to the power of minus t by tau. So this is the original expression, that is the source free expression. So that what we obtained for RC circuit. All right. So that means the response is divided in two parts. So one is its steady state part and transient part. So here steady state part, so this is independent of time, and this portion, so where we have multiplied by e to the power of minus t tau, so that means this is dependent part, so that's why dependent with time, so that's why it is known as transient part, okay, or the transient response. So one is steady state response and another one is its transient response. So each response is divided into two parts. One is the steady state part and the transient part. Steady state part is independent of time and the transient part is depends on the time. Okay. All right. So here we already done some things, right? So here the steady state, what is its steady state value? What is steady state value of this particular circuit? So that is V infinite, right? So what is V infinite?
Yes.
What is V infinite? Voltage across capacitor at infinite time, so which is equal to Vs, right? All right. So what is its steady state part? So what is its steady state part?
Sir, V, sir.
What is its steady state part? So earlier we have some things. If you observe that some equations we developed, right? So what kind of these things? So if you observe that all these things are depending on the time, all these things are depending on time. So that means this gives you the transient response, right? So this gives you the transient response. So that means it's steady state response. This is transient response. So we have two options depending on zeta value. If zeta is greater than 1, zeta is greater than 1, or zeta equal to 1, or zeta less than 1. What is zeta greater than 1? Which case it is?
Alpha greater than omega
Over
naught.
damped.
Over damped, critically damped, and under damped. So what is its solution? A1 e to the power of s1t plus A2 e to the power of s2t. Similarly, so this is A1 plus A2t into e to the power of minus alpha t, e to the power of minus alpha t into A1 cos omega dt plus A2 sin omega dt. Okay. So this is its transient part and this is its steady state part. So therefore, overall solution of V of t, right, it will be like this: A1 e to the power of S1t plus A2 e to the power of S2t plus its steady state value V infinite in this particular case, which is equal to Vs, or A1 plus A2t e to the power of minus alpha t plus V infinite, or e to the power of minus alpha t A1 cos omega dt plus A2 sin omega dt, okay, plus V of infinite. All right. So everything is same, right? So everything is same. Only the addition. So only the addition. So when you have source is this portion. So that means the steady state value is added. Simple thing, right? So earlier, if you assume that this is for underdamped response, if the response is something like this, it will be dies to 0, right? Earlier, that means when you have no source, right? When you have no source, in that case, this is the response, right? You remember this? Remember this, right? So this is the response when you have no source, right? So now what is the difference here? So if you have source here and the source voltage is, for example, Vs, so instead of that, so now it is varying like this. So now this is this axis. So now this value is Vs. That is the difference. That's all. Understood? Understood.
Yes, sir.
I think yesterday in one of the class we discussed this, right? So this is the main thing. So this is in case of underdamped. So it will start from some value. So it will be like this. So this value is, so this is its steady state value, which is equal to V infinite. If there is no such source, so this is the response. I think this is clumsy. I think this is visible, right? I'll mark with green color. So this is the one. And it is steady state value is 0. So whereas in the steady state value is V infinite. So that is the only difference. Understood? Okay. So it's simple step response of series RLC circuit. So that's simple. Similarly, this is about voltages, right? So this can be generalized. So these things can be generalized. For example, if you want a current I of t. So if you want current I of t, so how you will write the current response I of t? So this I of t can be represented IT infinite plus I transient part plus I steady state part. So what is I transient part? What is I transient part? So we have this expression, right? E1 S1t plus A2 e to the power S2t. So what is its I steady state part? So what is I steady state value?
0.
So I infinite, right? So which is equal
Fine.
to 0 in this particular case. Okay. So that means we can generalize earlier. If you note that when you have series connection, series RLC circuit, so somehow we managed to find the current value, right? So now in parallel RLC circuit, we found the voltage, right? We found the voltage across capacitor. So now the thing is, ultimately we can generalize the things. So whether it is current or voltage, the ultimate expression is I transient plus I steady state value. So this is the one. So we can safely replace with it is I of t or V of t, anything. It may be I of t or V of t. Either it is voltage across capacitor or the voltage across inductor or the voltage across capacitor or current through the inductor. The difference is instead of I of t, you will get one side I of t and here you have I of infinite. I of infinite. So that means you can generalize the things. So earlier, if you remember that in one of the problems, the question is I of t. I think in one problem, go back. We had seen this problem. If you remember that one of the problem, the question is, it's a series RLC circuit. It's a series RLC circuit. So instead we asked for I of t. So we asked for V of t. So what we did is we calculate I of t first. We calculated the I of t first. Right, we calculated the I of t first. So from that, so by integration, we calculated the V of t. By integration, we calculated the V of t. Right. So now what we can do is, so no need to, so do two steps. So directly we can assume that, so V of t itself is a1 e to the power of minus s1t, or whatever the solution is there, so that you can assume. Okay, right. So from that you can directly solve the problems. So no need to first calculate the current, and after that you need to calculate the voltage. So instead of that, you can directly assume that V of t equal to a1 into e to the power s1t plus a2 into e to the power s2 form, right? Or any of the form by finding its over damped case or under damped case or critically damped case, right? Understood? Similarly, in case of parallel RLC circuit, step response or forced response of a parallel RLC circuit. So let us assume that we have circuit something like this. Okay. So this is voltage across capacitor V. So this is inductor current I. Okay. This is R, L, and this is C. And this particular switch is open at t equal to 0, and this current value is IS. Right. So if you assume that this is node is the reference, so this voltage will be this capacitor voltage, this will be V, right? Okay. At t equal to 0, the switch is open. So that means this, so this entire thing is energized by this current source value IS. So this is energized by this current source value IS. So now what we can do is we can apply KVL or KCL at node voltage V at upper node, right? So what you will get, V by R plus I, what is the current? C into dV by dt equal to IS. Agree? Correct?
So this we are
Sir.
doing at t greater than or
Yes,
equal
sir.
to 0 now.
No, this is all we are doing for t greater than or equal to 0 only. Is this correct? Hmm? Right. So what is V here? What is V? If you know the inductor, this voltage is V, right? So that means this voltage is also V. So how you will express V if you know the inductor current?
L di by dt.
L
di
into
by dt.
di by dt. So substitute value of L di by dt here. So you will get L by R into di by dt plus I plus LC d, d square I by dt square, which is equal to IS. So divide this one with LC. So you will get d square I by dt square plus, what is the second term? 1 by RC into di by dt, right? Plus I by LC, which is equal to IS by LC. Is this correct? Just check it out.
Yes, sir.
Okay. All right. So now, so this I of t similar to this I transient of t plus I steady state of t. A transient of t and I steady state of t. So again you have I of t. What is the transient response? A1 e to the power of s1t plus A2 e to the power of s2t plus what is transient, what is steady state of t? It is I infinite, right? So this value
Yes,
is
sir.
equal to Is. Agree?
Yes, sir.
This is one case. Or
Sir.
A1, yes, into e to the power of minus alpha t plus Is or I infinite, or e to the power of minus alpha t A1 cos omega dt plus A2 sin omega dt into plus Is or I infinite. All right. Simple things, right?
So
Yes.
for here transient means for t less than 0 we are taking no, sir. Means natural response for t less than 0.
No, this everything is for t greater than or equal to 0 only. See here, there are two terms. So one response which is decaying with time and another one which is a steady state value. Okay. So one with time invariant value and the time variant value. So time invariant value means so its value will not change with the time. So that means V infinite or I infinite, that value will not change with time, right? So that is the steady state value. So in this particular case, right, so this Vs is its steady state value. So rest of the things, right, so that means that is varying with time or that is decaying with time. Understood?
Sir, at t equals to 0, I equals to 0.
No, what you're saying?
Sir, at time t equals to 0, current
Yeah.
0.
If t equal to 0,
Current in the inductor is 0 or not?
at t equal to 0, current in the inductor is 0 only in this particular case. Okay, if you solve some problems, you may understand. Right, so you can generalize this one. So for generalize, for example, some x of t you want to find, it may be x may be voltage or a current, right? So this can be found like this, x of t, so which is equal to x steady state of t plus x transient of t. So this steady state value, so that means x steady state, so when it reaches infinite time, and the transient, we have three cases, right? So any one of the case, so based on the RL values of the circuit, based on that RL value circuit. If it's a series RLC circuit, so we have alpha. What is alpha for R by 2L? In case of parallel RLC circuit, it will be 1 by 2 RC. Okay. So omega naught is common, so which is equal to 1 by square root LC. Right. So these are valid only for either the circuit falls in series or parallel. Okay. So these are only valid for if the circuit, the end circuit or the final circuit, it may be in the series RLC form or parallel RLC form. So we have generalized circuits, so that we'll discuss in the later classes. That means that will not come either in series or that will not come either in parallel. So generalized circuit, something like this. If this is the circuit, the source is connected here. If you notice that, so this will not comes under series or it will not comes under parallel, right? So these are the generalized circuits, right? So ultimately what we have to do is, what is the first step? What is the first step is, so we need to identify the circuit, and after that we have to see whether it is series RLC circuit or parallel RLC circuit. Okay. If it is series RLC circuit, we need to see So whether is with source or without source. So here also with source or without source. And after that, you need to calculate alpha value, omega naught value. So here also alpha value and omega naught value. So based on that, you need to choose either it is under damped, over damped, or critically damped. So based on that, so you need to choose the solution. So here also same, under damped, over damped, or critically damped. So we need to find a solution for this. Okay. All the things are for t greater than 0. To solve some problems, you may understand. So let us assume something like this, a circuit. Of Henry. So this is 6 ohm. This is the one we require voltage across capacitor. And this is 3 ohm. And this is 4 ohm. And this particular switch is this is not the one. Just a second. This erase these things. So this comes under the source free response of RLC circuit. Not this one. That is not the one. I think that we already discussed the problem. This is 15 volts. So this is 2.5 Henry. And this is 10 ohm. Okay. So this is 1 by 40 farad. So plus minus voltage V here. And this is I here. So this is 18 volts. And this is 1 ohm. And this is 2 ohm. Okay. So initially, the switch B is at position A, and at t equal to 0, switch is moved to position B or position C. Okay. It's initially at position A and it's moved to position C at t equal to 0. So find the overall response, or find what we find V of t. For t greater than 0. Right. What is the first step? So first step is finding the initial conditions, right? V of 0 and I of 0. What is V of 0?
12 ohm, sorry, 12 volt.
V of 0 is 12 volts. So how it is 12 volts?
Voltage across
So
2
it
ohm
will be
resistor.
circuit like this, right? Plus minus here. So this switch is initially at position B, right? So this is the circuit, right? Agree?
Yes, sir.
So
6
this is
volts.
18 volts, and this is 1 ohm, and this is 2 ohm, right? So what is the voltage across 2 ohm resistor? So that is the voltage
Well,
across 2 ohm resistor and the capacitor open circuit voltage. So both are same, right? So what is the voltage across 18 into 2 by 2 plus 1? so which is equal to 12 volts, right? Right. So now what is the inductor current? What is
Zero.
inductor current? So it will be 0. So why it is 0? We have switch here, but the switch C here. So this switch is moved only after t equal to 0. So therefore this current I equal to 0. So that means this is 0 amperes. Understood? So once the initial conditions are over, so this is for t less than 0. So for t greater than 0, we need to develop the circuit. So for t greater than 0, the switch is moved to position C. So therefore the circuit will look like this. Okay. So this is the circuit, right? So we have found that what comes under this. So it is a series RLC circuit, right? So we derived some steps, right? So first one, it's a series RLC circuit. And with source or without source?
With source.
With source, right? What is the next step? So we need to find the value of alpha. What is alpha? Series RLC circuit, what is the formula for alpha?
R by 2L.
R by 2L, right? So what is R by 2L? In this particular circuit, what is R by 2L?
Sir, 2, sir.
2 and omega naught? What is omega naught?
1, 2.
No.
Sorry.
1 by, I think 4, I think. Check it out.
4.
4. L is 2.5 and 1.40, right? So that means it will be under root 16. You will get
Sir.
1 by
4, sir.
16 you will get, right? That means under root 16, that means 4 only. Okay. So now alpha is greater than omega naught. So what kind of response it is?
Underdamped.
Underdamped, right? If it is underdamped, so what is the next step you need to do is immediately you need to calculate the omega d value. So what is omega d? Square root omega naught square minus alpha square, right? So what is omega d? Root 12, right? Root
Yes,
12,
sir.
right? Okay. So now what we have to calculate is V of t, right? V of t, they are asked for V of t, right? So what is V of t? So V steady state plus V transient. So that means A1, e to the power of minus alpha t. Alpha is 2 or 4? 4, right? Minus 4t into A1 cos omega d is, yes,
Alpha is 2.
alpha is 2, 2t root 12 t plus A2 into sine root 12 t plus what will come after this?
Sir, 15.
Infinite.
V infinite, right? So what is V infinite
15.
in this
15.
circuit? So what is the V infinite in this circuit? What is V infinite? So which is equal to 15, right? Steady state voltage across the capacitor is 15 volts. Okay. All right. So we have some initial conditions. So V of 0, what is V of 0? 12 volts, I think. 12 volts. V of 0 is 12 volts, no?
Yes, sir.
Okay. So substitute here. So 15 plus, I think A1, 15 plus A1 equal to 12. Is this correct? So A1 equal to minus 3. Just check it out.
Correct, sir.
A1 is minus 3, right? Agree? A1 is minus 3. Right. So now this is one initial condition or one thing. Right. So now what is the other initial conditions you require? What is the other initial condition you require for this
I
V
of
of
0
t?
is 0.
Hmm?
I of 0 is 0.
See here calculating the
dv
voltage,
of
right?
0
dv of 0 by dt you required, right? Agree?
Yes, sir.
See here you are ultimately you are measuring or you are finding the response for V of t, right? You require two initial conditions, V of 0, dV of 0 by dt. So if it is a current I of t, so it will be I of 0 and you require di of 0 by dt. So that is the fundamental thing, right? Understood? So what is dV of 0 by dt? What is dV of 0 by dt?
minus 1 by c v naught plus r I naught by r.
See here, if you observe that we can calculate that, right? So you know what is the current? What is the current in the circuit? I'm erasing this. We just found the initial conditions for, right? How to find the initial conditions? We studied in one of the class. This is 15 volts. I think this is 10 ohm. What is this value? 2.5 Henry. And this is 1 by 40 farad. Okay. Right. So this is the inductor current I, right? So this is capacitor voltage V. So what is the capacitor current?
C
What is the
dv by dt.
capacitor current? So same as inductor current, right? You know the capacitor, you know that basic thing is, what is the basic thing? IC, if you assume this is the capacitor current IC. So what is IC? If you know the voltage across capacitor,
C dv by dt.
dV by dt.
dV by dt.
C into dV by dt, right? You know IC of 0 value? Do you know IC of 0 value?
Yes, sir.
Yes, 0.
Yes, sir.
0.
So how you know that? So this is a series connection. So which is equal to IC of 0, which is equal to I of 0. So that is inductor current. Which is inductor current, which is L equal to 0. Understood? So now tell me what is dV of 0 by dt? So which is equal to IC of 0 by C. Agree? IC of 0 by C. So what is IC of 0? Which is equal to I of 0. So that means 0 volts per second. Which is equal to 0 volts per second in this particular case. Understood? Understood?
Yes, sir.
Okay.
Yes, sir.
So what is the next step? What is the next step? We need to find dV of t by dt. And after that is substitute t equal to 0. And equate that entire thing equal to 0, right? So what is dV of t by dt? So find out dV of t by dt. So what you will get? So minus 2 into e to the power of minus 2t, right? Plus a1 cos root 12t plus a2 sine root 12t, right? So this is the first term. So what is the second term? E to the power of minus 2t into a1 root 12 or root 12 a1 minus, I think, sine root 12t plus root 12 a2 cos root 12t. Is this correct?
Yes, sir.
Okay. So substitute t equal to 0. So it will be dV of 0 by dt. So what you will get if you substitute t equal to 0? I think one more term is there, right? Some 15. I think 15
Sir,
is there,
but
right?
that will
Integration
become
under
zero,
15
sir.
is
It is
0.
zero now, sir.
It
Okay.
becomes zero.
I will, for more brevity, I will write 0 plus 0. Okay. So with t equal to 0, what is dv of 0 by dt?
0.
So
Sir,
A2 comes out to be 0 only.
root 12
12
A2 minus 2A1.
A2 minus 2A1 equal to 0. This is equal to 0. This entire thing is equal to 0, right?
Sir,
Is this correct?
negative sign is there before 2A1.
Minus 2A.
Minus 2.
Is this correct?
Yes, sir.
Yes, sir.
Correct.
Hmm? Yes or no?
Sir,
Correct,
root
sir.
12 A2 before sign is plus.
This one.
And yes, sir.
12A2 minus 2A1 equal to 0.
Yes, sir.
Okay. 12A2 minus 2A1. Yeah, correct only. Right. So now what is the value of A2? A1 is already known to you, right? A1 is minus 3, I think. What
Minus
is
root
A2?
3.
Root 3, sir.
Minus root 3.
Minus root 3. A2 is minus root 3. Okay. So that means overall solution V of t equal to, what is V of t? So we have 15 plus, what is the first term? What is the first term? A1, right? So both are with minus. So that means 15 minus, I'm writing minus here. So A1 is 3. A1 is 3 only, right? Minus 3. That means 3 into cos root 12t plus root 3 into sine root 12t. Is this correct?
Yes, sir.
Hmm?
So e power minus
No, into e to the power of e to the power of minus 2t.
Sir,
Yes.
so whenever, sir, means irrespective of parallel or series RLC circuit, sir, whenever in question VT is asked, sir, that implies that voltage across sir capacitor, and sir, when IT is asked, that means sir current that is passing through inductor now.
No, that will show in the diagram, no? In the question is given, right? So that will show in the diagram. Okay. It
So
not
like in
necessary
this
to be.
question, sir, it will be across capacitor now, VT.
No, this will be across capacitor only. Okay.
Okay, sir.
Right. So for the same question, right, if you want to calculate, for example, VR, voltage across resistor at t equal to 0. So how do you calculate that? What is voltage across capacitor? What is voltage across capacitor? What is voltage across capacitor in this particular case? So will it be R into I of t, right? Agree? R into I of t, right?
yes, sir.
Okay.
Yes, sir.
So what is I of t? What is I of t? If you know the voltage across the capacitor, what is I of t?
C dV by dt.
C into dV by dt. So that means this will be R into C dV by dt. So you can differentiate this one, or you can find the RC into dV by dt. Okay. Or this is one way, or straight away this I of t is there, right? You can also see here, you are written the expression for dv of t. Similarly, you can write I of t. So y transient of t plus I steady state of t plus that thing. So you can implement that and straight away you can multiply with R. So that gives you the voltage across the resistor. Okay. So no need to do this derivative part. If the question is only so VR of t, the question is only VR of t. So in that case, what we have to do is we need to find I of t. We need to find I of t. So I of t can be written as I transient part plus I steady state part. So from that you can do the rest of the things. Understood? So based on the questions, we need to either calculate I of t or V of t, so that we will select. So we have another question. Yes.
Sir, voltage across inductor will be the difference between total minus all the voltages, no, sir.
Voltage across inductor L into di by dt, no? VL.
We need to differentiate 2 times, no, sir. That's why, sir.
Why differentiate
Can we
2
do-
times?
Can we do Vs minus VR minus VC?
It will become complex, no? What you are saying in this problem, if VL of t, if you want to calculate VL of t, how to calculate that? That is your question, right?
Yes, sir.
Okay. Right. There are 2 ways to do this. There are 2 ways to do this. So one way is, okay, so L into, you can, what is inductor d into di by dt, right? Agree?
Yes, sir.
So calculate I of t. So after that, you can calculate this one. That is one way. Okay. Another
Yes,
way
sir.
is VL of t, so which is equal to VL of t transient part plus VL of t steady state part. That also you can do.
Okay, sir.
Okay. So this will be slightly complex because to find out the initial conditions, we need to calculate the initial condition. Inductor current for 0 instant we need to calculate, right? So that may be complex, right? So the best way is, so find the I of t value and after that you differentiate that one. That will gives you L into di by dt. Okay. Understood. So next we have another question. This is 1 by 25 farad. This is 1 Henry. And this is 5 ohm. And this is 5 ohm again. And this switch is closed at t equal to 0. And this is 20 ohm. And this is 100 volts. If this is the current, inductor current I, so calculate I of t. Calculate I of t. Okay. So what first step is required? So V0, right? And I0. So what is V0 and I0?
I0 is 0, sir.
I0 is 0. Yeah, how it is 0? Because this capacitor is open circuited, right? Because this capacitor is open circuited, I0 is 0 amperes, right? So what is V0?
50 by 3 volts.
50 by 3.
50 by 3. So no need to explain this, right? Okay, so how the circuit will modify, that is important, right? So this switch is open, right? So that means No, the switch is closed, no? This will not be there. Okay. This is the circuit, agree? So what is the value here? 20 ohm, and this is 100 volts, and this is 5 ohm, and this is 1 Henry, and this is 1 by 25 farad. Understood? This is the circuit, right? If the switch is closed, so if this switch is closed, right? So the current through this 5 ohm resistor is 0. So that's why we remove that portion. Right. So will it be series RLC circuit or parallel RLC circuit? Will it be a series RLC circuit or a parallel RLC circuit? That's the question. What kind of circuit it is? Or can we alter the circuit so that it will be series or parallel RLC circuit? How to alter this circuit? So we want to bring this circuit in this form, right?
Yes, sir.
How to bring this circuit in this form? Is this possible? So this parallel circuit, this parallel resistance is the creating problem, right? So how to remove this parallel branch? How to remove this parallel branch? That's my question. How to remove that parallel branch? So can we apply source transformation? If you apply source transformation, right? So if you convert this into equivalent, for example, this thing, if you convert this into equivalent resistance, what you will get here? This is the circuit, right? What is this value?
Ampere.
So 100 by
5
2. This is 5 ampere. And what is this value?
20 ohm.
20 ohm. And what is this value?
5 ohm.
5 ohm.
5 ohm.
And this is 1 Henry. And here you have 1 by 25 farad. So now these two one comes in parallel, right? 20 and 5. If it comes in parallel, what the value you will get? 20 ohm and 5 ohm will comes in parallel, right? So what is the value you will get? 4 ohm.
Yes, sir.
Yes, sir.
So 4 ohm, right? So now we have the circuit is deduced like this. So this is 4 ohm and this is 5 amperes. Still, it is not the one that we required, right? So how to convert this again?
Into voltage
Voltage
source.
Again
form.
convert to
Convert
voltage
into
source.
voltage source, right? So this will be now 5 into 4, 20 volts. So this will be 4 ohm. Okay. So this is the overall circuit, right? This is 4 ohm. What is this value? This is 1 Henry here, and this capacitor is 1 by 25 farad. All right. So now we can do this, right? So how to do that? First calculate the alpha value based on that I of the solution. So you need to find. So if you do that, I think I have answer. You just cross verify it. Okay, that is the answer. You can cross verify it. You have any questions in today's class? You have any questions?